Let's calculate the cross-entropy loss for our example. Recall where we left off is that we computed the probability that our movie review, so don't forget we had X was a movie review, and we calculated that the probability for this movie review being positive is 0.7, and since the probability of being negative is 1 minus this value, 0.3. And now we can calculate the cross-entropy loss by simply plugging in numbers. And here we can make two assumptions. Let's assume our model was right. So in this case, indeed, the true value was 1, meaning positive, or the true value is 0, meaning negative. And apart from this, we just plug in the numbers. And plugging in numbers means that we get a loss for being correct as 0.36 and a loss of 0.1 of being wrong. And this is quite intuitive that the loss of being right is lower than the loss of being wrong. On the other hand, it's also obvious that the loss is not 0 because our prediction is not 1. Our prediction is only 0.7 and not 1. So our loss, even if we are correct, because we predict positive, since our value is larger than 0.5. But we could have technically make a better prediction. We could have predicted 0.9. So for example, 0.9 would even be better. And this will result in an even lower loss. So even if you make the right prediction, doesn't mean our loss is 0, because the predicted probability might not be exactly 0.1, which will actually never happen in practice. So in practice, the loss will always be non-zero, apart from any kind of rounding issues.